Imagine a universe built from a handful of fundamental ingredients. These are the elements, the stars in the microscopic cosmos of matter. This video will explore the remarkable diversity and interconnectedness of these building blocks of reality and the history of it. The periodic table, a seemingly simple arrangement of symbols, represents the fundamental building blocks of our universe. This essay will explore the fascinating properties and behaviors of the elements, delving into their atomic structures, chemical interactions, and their crucial roles in shaping the world around us. What are the fundamental substances that make up everything we see and touch? From the air we breathe to the ground beneath our feet, the answer lies in the elements. This essay will embark on a journey to uncover the secrets of these essential components of the universe. Our journey begins with the ancient Greeks. In the 5th century BCE, Empedocles proposed that all matter was made of 4 basic elements: earth, air, fire, and water. Later, Aristotle expanded on this idea, adding a 5th element, ether, believed to make up the heavens. In China, the 5 elements wood, fire, earth, metal, and water were used in medicine and philosophy, shaping their understanding of nature. Similarly, Indian philosophy described Pancha Mahabhuta, 5 great elements: earth, water, fire, air, and space, which formed the basis of the physical world. Alchemy was an ancient form of chemistry practiced by Greeks, Egyptians, Chinese, Indians, and medieval Europeans. Alchemists believed they could transform materials, like turning lead into gold or finding a magical substance called the Philosopher's Stone, which they thought could make people live forever. Even though their ideas were often unscientific, alchemists accidentally discovered many chemical processes like distillation, fermentation, and metalworking. Robert Boyle was an Irish scientist who helped turn alchemy into real chemistry. He discovered that when you squeeze gas into a smaller space, its pressure increases. This was a big breakthrough in understanding how air and gases work. Unlike alchemists, Boyle believed in experimenting, testing ideas, and proving them with evidence, and he held that substances are made of tiny particles, atoms and molecules, not magical forces, and that chemistry should be based on science, not superstition.
The scientific revolution, 1500s, 1700s, was a time when people started using experiments, observations, and logic to understand the world instead of relying only on religion, tradition, or ancient texts. Before this, most people believed what the church or ancient philosophers like Aristotle said about nature, even if it was wrong. But scientists began testing ideas, making discoveries, and creating new inventions, leading to modern science.
Then, in 1869, a Russian man named Dmitry Mendeleev revolutionized chemistry by organizing the elements into a table, predicting properties of elements yet to be discovered, and organized the different elements into what we know today the modern periodic table of elements.
Throughout the 19th century, new elements such as calcium, potassium, and radium were discovered. The discovery of radioactivity by Henri Becquerel, 1896, and later by Marie Curie and Pierre Curie, led to new elements such as radium and polonium. This era also saw Ernest Rutherford and Niels Bohr revolutionize atomic theory, introducing the model of the atom with a nucleus. The electron was discovered by J.J. Thomson in 1897, and neutrons were identified by James Chadwick in 1932. On 1914 until 1918, the World War I has begun across Europe. During this time, chemical warfare was introduced. The use of chemical weapons during World War I, such as chlorine gas, showcased the destructive potential of chemical elements. This spurred further interest in the chemical properties and weaponization of elements. In 1939 until 1945, World War II has erupted, also called by many as the nuclear age. The discovery of nuclear fission by Otto Hahn and Fritz Strassmann in the late 1930s led to the development of the atomic bomb in the Manhattan Project. This resulted in the first nuclear explosions in 1945, forever changing the understanding of atomic energy and elements. Scientists discovered that splitting uranium U-235 or plutonium Pu-239 atoms releases huge amounts of energy, nuclear fission. This led to the creation of the first atomic bombs. On 6 August 1945, the United States dropped 2 atomic bombs in Hiroshima and Nagasaki. Hiroshima, little boy. Uranium bomb. 9 August 1945 in Nagasaki. The Fat Man was dropped, and it was a plutonium bomb.
Once upon a time there was a tavern where we used to raise a glass or two.
During the Cold War, elements played a crucial role. The discovery of plutonium Pu and uranium U led to the creation of nuclear bombs, with the USSR testing its first atomic bomb in 1949. In the space race, elements like aluminum and titanium were vital for rocket building. In 1957, the USSR launched Sputnik, the first satellite. By 1961, hydrogen H, in the form of hydrogen bombs, became a focus for both superpowers, showcasing atomic advancements. During the space race, 1957-1968, scientists discovered new elements while advancing nuclear and space technology. Lawrencium Lr. 1961 was synthesized in the US, while Nobelium No. 1957-1958 was first claimed by the USSR, but later confirmed by American and Swedish scientists. These super-heavy elements were crucial for nuclear research. Meanwhile, elements like titanium Ti and aluminum LLR were vital for building rockets and spacecraft, shaping space exploration. From 1968 to 1991, the USSR made notable discoveries in the field of chemistry and nuclear science. In 1970, element 104, Rutherfordium RF, was claimed to have been discovered by Soviet scientists. They also contributed to the discovery of super-heavy elements like element 105, dubnium D, in the 1960s. The Soviets continued nuclear research, producing isotopes for medicine and energy, and refining technologies for nuclear reactors and space missions, advancing the global scientific community. After the Cold War ended in 1991, scientific research into the discovery of new elements accelerated, with a focus on super-heavy elements. These elements, which are heavier than uranium, do not occur naturally and can only be synthesized in laboratories. In 1994, Darmstadtium D's element 110 was first synthesized by German scientists at GSI Helmholtz Center. This marked a significant advancement in the ongoing effort to extend the periodic table beyond uranium. In the following years, more super-heavy elements were discovered. In 1996, Roentgenium J element 118 was synthesized at GSI, named after physicist Wilhelm Röntgen. By 2002, scientists confirmed the creation of Copernicium CN element 1112 at the GSI, named in honor of Nicolaus Copernicus. These discoveries were pivotal in understanding nuclear chemistry, marking significant steps forward in the field of synthetic element creation and contributing to the study of nuclear stability. From ancient civilizations to modern times, the discovery of elements has shaped our understanding of the universe. Early thinkers like the Greeks and Romans laid the groundwork, while the scientific revolution sparked new methods of experimentation. The Cold War saw the birth of nuclear technology and space exploration, and today, global collaboration continues to push the boundaries of science. The journey from ancient alchemy to modern atomic research is a testament to humanity's relentless quest for knowledge. But thank you for watching this mini documentary about the historical timeline of discoveries, usage and evolution of different elements. From ancient civilizations to modern breakthroughs, the story of elements continues to shape our world even in our today's time. Stay curious and keep exploring the wonders of science. See you in the next video.